And I'm back with 7-2 Angle Relationships and Triangles, Part 2. These are the problems that were a little more complex and have a little bit more going on. And so I wanted to be able to dedicate a day to these because I feel like they're going to be confusing and complicated for you guys. Okay, so this is on page 401 in your workbook. All right. And they're asking us to find the measures of angles CDE and VCE. All right. Well, let's color code this for starters. Oh, no, I need to be on pen. Red pen. Okay. Measure of angle CDE. Where is CDE? Start with C and then follow to D and then E. This is the angle they're talking about right here, this one. We know this is 3y, okay? So the measure of angle CDE is equal to 3y, okay? The other one that they want us to find is the measure of angle BCE. BCE. So that would be this one right here, the blue angle. And we know BCE, the measure of angle BCE, is equal to 3x minus 21. Okay? Well, here's what we know. We know because of that exterior angle theorem that this angle here is going to be equal to this angle plus this angle, okay? These two angles added together will equal this exterior angle. That's because this angle and this angle equal 180, and this angle and these angles equal 180. Therefore, these two angles have to be equal to this one, all right? That's our exterior angle theorem. So we know that 3x minus 21 is equal to 42, that's this guy right here, plus this guy, plus 2x minus 21, right? So we can subtract 21 from 42. Let's kind of clean this up a little bit. If we subtract the 21 from the 42, we get 21 plus 2x, all right? Now I want to get all my variables on one side, so I'm going to get rid of the smaller variable, the 2x, by subtracting it from both sides. This gives me x minus 21 equals 21, all right? Therefore, x is 0. That's kind of weird. No, it's not. Strike that. If I add 21 to both sides, x is 42. Okay. Kind of coincidental that this is 42. I wonder if they did that on purpose or if that was an accident. Anyway, this one would be 2 times 42 minus 21. And this little blue guy, the one we're trying to solve for, he's 3x minus 21. So we take the 3x minus 21, we take out the x and we put in the 42 minus 21. 3 times 42 is 126. Doing math in my head, very dangerous. And let's see, 126 minus 21 would be 105. Okay, so that would tell us that the measure of this angle is 105. Okay, and that seems right to me because this is definitely an obtuse angle. It's bigger than 90 degrees. And I feel like 105 is just a little bigger than 90 degrees. But now that I know that this angle here is 105, that also tells me that this angle here is 75. Because this one plus this one equals 180. So 75 plus 105 is 180. That helps me find these other two angles here. Because I know that the measure of this angle here, this one right here, well, I guess the 75 doesn't really help me because it's this angle right here that is equal to this one plus this one. So knowing that this one here is 105, I can do, switch to red, because I'm solving for the red angle now. I can do that 105 is equal to, this guy right here, 105, is equal to this angle plus this angle. So he's equal to 3y plus 2y. So 105 is equal to 5y. And that when I divide both sides by 5, I get that y is 21. Okay, So what was the angle I was trying to solve for in this triangle? This one right here. It's 3 times y. Well, 3 times y, I take the y out, I put the 21 in. That gives me 63. That look right? Yeah, I think it looks right. So this one is actually 63 degrees because they don't want to know what y is. They want to know what's the measure of this angle. Okay, this angle is 3 times y. All right. So you can see why I didn't want to tack this onto an already long instructional video, because this really takes some thinking and it takes some time to explain. So that's why I decided to split it up into 2 days. Here we have another example that is on page 402. It's very similar to the last one. We're going to set this up very much the same way. All right. Only this time they're asking us to find 3 angles. Holy cow. They want FDE. Let's see if I can find it. FDE. So they want this guy right here. This is going to be our red angle. The measure of angle FDE is the red one. We'll go blue for the next one, DEF. DEF, that's this one right here. Measure of angle DEF. I'm going to need a new color. How about green? Let's go with green. FHG. FHG is this one right here. This is our green angle. The measure of angle FHG. Okay, so let's start. What's going to be the best one to start with? Oh, yes, definitely going to solve for x first. How did I choose that? Well, I know that this angle is 2x, this angle is 3x, and I have the exterior angle here. So this is the better one to start solving. This triangle's missing one. I know this angle is equal to y, but I have no idea what this angle is. So I do know that it's equal to this one, see, because those are alternate interior angles. So this one would be equal to this one, but I don't know what this is yet. So that's what we're going to do first. We're going to solve for the red angle first. Okay, so we go to red pen. All right. Solving for this one, I know that 110 has to equal 3x plus 2x. So the measure of that's the exterior angle there, the 110, and it has to equal 3x plus 2x. Okay, so measure of angle 110 equals 5x. Divide both sides by 5, and I get that x is 22. Okay, so now that I know x is 22, can I solve for D, this guy right here? Yes, I can, because I know that he's equal to 2x. Well, if x is 22, what's 2x? 44. Just multiply it times 2. So the measure of this angle is 44. Do I also know the measure of this angle, the blue angle? Yeah, I found that by solving for x, because it's 3x. So 3x, and x is 22, is 3 times 22, which is 66. So I know this one is 66. And does that help me solve for the last one? You bet it does, because that tells me if this angle is 66, this angle is also 66. It's alternate interior with this one, okay? Now I can say that 110 is equal to 66 plus y, because this is an exterior angle, and it's equal to the 2 remote interior angles added together. So, solving for the green angle, I know that 110 is equal to 66 plus y. So if I subtract 66 from both sides, oh boy, I'm going to use a calculator. I'll screw that up for sure if I try to do that in my head. I haven't done math for a week. I'm never going to make it through that one. 66. 44. Yeah, I guess that makes sense. 44 is equal to y. All right, and since this angle was just y, we don't have to multiply it or anything. It is just 44. Okay, so we had that angle was 44, this one was 66, and this one was also 44. which makes sense. I probably could have solved this without killing myself because I knew this was 44 and it's alternate interior with this one. So I probably didn't have to do this work. I could have just used that rule and said this is alternate interior with that one, so it has to be the same as this one. As you can see, that's how it worked out. All right, so that brings us to the practice problems. Practice problems will be a different video. And so that's all for the 7-2 part 2 video. All right, I hope you do well on the McGraw-Hill problems. All right, and I will see you in the practice problem video.